Welcome GibbsCAM users. Today we're going to show you how to program a Doosan Lynx or Puma, both very similar machines in the way they program. The Lynx is a linear machine and the Puma is a boxway machine, a little more heavy duty cutting with the Puma, and both are very popular machines around the world. This video is going to be from start to end on this part. I've already loaded the post processor up there, and that includes the MDD and VMM. Now, if you're not familiar with what an MDD and a VMM is, that's okay. That means when you load up the post processor, it knows how many stations are on the turret. If it has a sub-spindle, y-axis, live tooling, milling, etc., everything about that machine is known in the post. So let's get started here. I'm going to be making some mistakes along the way on purpose, so these are common mistakes people make, and we'll show you how to fix them as well. So let's get started. I'm going to go to File and New. I'm just going to call this, we'll call it Doosan Lynx Puma. And it's going to open up a blank screen for us. Next, I'm going to choose the machine, so I'll go to Document Control. And you can see there's a whole tool list here of the different machines that I have in mind. Yours will be different. I'm going to choose this post right here. And I'm not going to really fill in any blanks here quite yet. Now it's going to open up a blank screen, and the screen may or may not look like mine when you open it up, but that's okay. So the first thing we want to do is, of course, import the file. So let's go to File. We're going to be using a solid model. So let's do import, and this is going to be an MTM part 4. As you can see, there's a little preview here. It's a SolidWorks file, so I'm going to click on Open, and it's going to bring it into Gibbs. Now, as with all solid models, when you bring in a solid model into Gibbs, it's going to put the origin where the engineer decided to put his origin on the part when he engineered the part. And as you can see here, the Z0 is a little bit behind the part here. Now there's a couple ways to put the Z on the front. You can either right-click and say move the part origin to the front. But an easier way for me is I'm just going to go to Modify and click on Shrink Wrap. That'll wrap material around the whole part there, and this will tell me the actual size of the material or the part that I've imported. Now, as you can see, I have the main spindle, sub-spindle here, which is somewhat annoying when you go to unzoom, because you want to work on the main spindle or the sub-spindle, and so you have to pan over. So to eliminate that, if you go up to the part stations, and as you can see, it has both the main and the sub-spindle open. I'm just going to close the eye on the sub-spindle. Now when I go to unzoom, you'll see it's only working on the main spindle here. When I get to the sub-spindle, I'll turn this back on. So for right now, I have a shrink wrap. Go to Document Control. And as you can see, it says there is material. There's 128 thousandths of material from my Z0 to the front of the part. Well, we always want to program the front of the part as Z0. So when we face off our part at Z0, that will be the actual front of the part. So let's move that just by going to Modify, Move Part Origin. I'm just going to move the Z 128 thousandths, and as you can see, it says Z0 now, and my Z is in the front of the part. Now before I do the diameter of the part, as you can see, doing a shrink wrap does not take into account the flats here, or this little flange here. So first thing I'm going to do, click on my part, and the easiest way to get geometry off of a solid model when you're turning is to go up here to the what we call the profiler, and there's 4 different choices up here. The slice plane, which we use a lot for the XY and YZ, and this one here says slice spun body. So what that does is it gives you the geometry as if the part was spinning in a lathe. And as you can see, if I click here, right click and go to extract the profile, then I turn this profiler off. As you can see, there's the geometry to cut this whole part as far as the turning goes. And as you can see, this is higher up here. That's because this is the diameter it would be when it's turning the part. So now if I did a Modify Shrink Wrap again, now you can see this has changed. So it wrapped geometry, or sorry, it wrapped stock around the part here. If I go to my document control now, you will see this says it's 4.069 would be the material we need to cut the outside of that and clear the part. Well, you're not going to find material 4.069, so the closest material is 4 1/4. So we're going to say 4 1/4 there. Now we want to add a little material on the front of the part and the back of the part as well. You're not going to cut your material with the saw right to size, so we need to have some material there. So I'm going to add 1/8 of an inch to the front of that, and as you can see, the stock just moved 1/8 of an inch. And our part is minus 1.125 to the back here, so I'm going to add 1/8 of an inch to that as well. So I'll just go minus 0.125. And so I have 1 1/4 there. So the overall length will be 1 3/8 total length on here. So I have 1/8 inch in front, an extra 1/8 inch in back, and as you can see that here right on the screen. So now we have to decide where we're going to grab the part with the chuck. I'm probably going to grab approximately right around here. Probably stay away from this flange, because when I mill the flange, I'm going to do that on the main spindle. I need to have a little extra there so I'm not actually cutting into the jaws with my end mill. Now I'm going to add a couple of extra points in here just as reference to where I'm going to grab on with my main spindle and where I'm going to grab with my sub spindle. So I'm just going to turn on geometry palette. I'll click on point XYZ, and my first point is going to be minus 1.250, just like it says down here on there. And the diameter, I'm just going to put 4 1/4, just like our material is. So there's a point right there. So this is right on the end of the part here. Now I want to grab onto this part 1/4 inch, so I'm just going to put another point here at 1/4 inch and at 0 degrees. So this is where I'm actually going to grab with my jaws right here. So this will give me a little leeway here as well. Now on this, I'm probably going to grab right about here. Let's just dimension that just so we can see where we're at. So I'll dimension that. So that is Z minus 595. I'm probably going to add, actually grab on at 1/2 inch there. So I'm just going to go, click a point. I'm going to say minus 0.5. And we'll go, since that's about 2 3/4 diameter, I'll just put 2 3/4. So this is where I'm actually going to grab with the sub spindle. So if I was to dimension some things there, I dimension, well, let's just dimension from here to here. You can see that's 3/8. Whoops, let me bring that on here. 3/8. Grabbing on right there, which you can see is 1/4 inch, and it's 3/8 from there, as you can see. And if I were to dimension from the front of the part to where I'm actually going to grab with the sub spindle, you can see that's 1/2 inch there. Okay, and you can always turn dimensions off here if they get in the way. So now we have our turning defined here. Next, we're going to bring in our tools. So I'm going to turn on our tool palette. And I already have the tools predefined, so I'm going to actually import those in, and we'll go through them. So if you already have the tool list saved, which is a good idea, that way you don't have to create them each time. I'm just going to go load tools, and I already set the folder where I stored all my tool data, Doosan tool list. And as you can see, here's the tools. So we'll go through each one of the tools individually. So the first tool I'm going to use is the 1 1/8 drill. This is basically an indexable drill. So it's almost flat at the end. So I usually put about 175 degrees on there. It's not quite flat. So this will give me the closest approximation to actually what the drill is. Of course, you could always import a solid model if you wanted exact, but this is good enough for what we're doing. I have this in position number 1, 2 flutes, tool length offset 1 and 1, and this is just actually carbide insert. And and I usually give it a name here so when I'm looking at the code out on the machine I can see if this tool is going to the main spindle or sub spindle. So that's what I usually put right at the beginning on there. Makes it much easier. Also makes it much easier when you hover your mouse over to here, it'll pop up that note saying this is main spindle drill static or whatever name you gave that. So the next tool is going to be 8-degree diamond CNMG, 32nd tool nose radius, 1/2 inch IC, thickness 1/8 or 3/16. You can choose either one of those depending on what you have. Even if you chose 1/8 inch or 3/16 or 5/16, the G-code output's going to be the same. What this will do is just bring up different ANSI holders there based on the thickness there. And as you can see, I have a drop-down menu here. If I was to drop this down, you would see this is the different standard ANSI tool holders, various types there. So you can choose that. The most common here is going to be a 5-degree face relief. And this is going to be in position number 2, offset number 2. And you see this, you have this button here that says insert face up, face down. Of course, if this was face up, that would be an M4 on your spindle rotation, or this would be an M3 in most machine tools. At least Fanuc controls should be an M3 on there. That's normal rotation. I like to have the inserts facing backwards. It throws the chips to the back of the machine instead of towards the front of the machine, which is a lot safer. So that's good there. The next tool, tool number 3, is going to be a 55-degree, again, 5-degree face relief. Position 3, offset number 3. Let's go through some of the, well, the next one is actually a boring bar. Position number 4, offset 4, insert to the back side again. Now we get to the milling tools here. This is my first live tool. This is a spot drill, and it's pointing in this direction here. So make sure you get that correct. That's in position number 5. It's a live tool. And offset 5, cutter comp 5. Next one is a 3/8 end mill, finish end mill, 3/8, position number 6, offset 6, 6. 7 is a 1/2 inch end mill, offset 7, 7, position 7. And the last tool for the main spindle is going to be an 1/8 inch, or sorry, 1/4 inch drill, tool offset 8 and 8. Now we get to the sub-spindle tools. Now I usually put a gap in between the main spindles tools and the sub-spindle tools just so I can see that all these down here are for the sub-spindle. Now when you're working an MTM, just because I have this in position number 12 does not mean it's going to be in the turret position number 12. This is just a placeholder, so don't worry about these numbers so much here on where it's going to go in the turret. So if I do the sub-spindle tools, this is the same as the main spindle tools as far as position goes. I'm going to put this in position number 2, which is the same as the main spindle. You can see the main spindle was position number 2, and this one is also in position number 2. But since I have a tooling block that holds 2 tools, one for the main, one for the sub, I can use this same position. But I need to give it a different offset. We don't want to use the same offset that we used for the main spindle. So I'm going to add 20 to the offset. So this is going to be position number 2, offset 22. So that's going to be output T0222. And everything out there is the same. You can choose whether to have insert face up. Some people like to do the sub that way. I prefer to have it force the chips to the back of the machine as well on the sub spindle. So here we have same thing, position number 4, same as this one up here. And I add 20 to the offset, which will make this 24. 55 degree will be on position number 3, same as the main spindle. And offset 23. And the last tool, the 3/8 combination spot drill chamfer tool, will be in position number 5. And this needs to be actually offset. Add 20 to that, that'll be 25 and 25 there on that tool. Okay, so now we have all our tools defined here. Now let's go ahead and start to machine this part. Let's turn off our dimensions here. And before I start machining, I'm going to make a few different work groups here. This first work group, I'm going to name this main and sub turning. Let's expand this just a little bit. Scoot this over a little bit. So I'm going to make a new work group, and this one I'm going to call milling main sub. Okay, so now I have my work groups named, and of course you can create as many work groups as you want if you want to separate the geometry here, because sometimes if you have too much geometry in one work group, then it overlaps and it's a little bit hard to choose. So that's fine, you can create as many as you like. Now when you have the MTM post-processor loaded for this type of machine, you will automatically have 6 coordinate systems already defined. I actually added these two windows together here, so when I drag them they both kind of match up with each other, so that's fine. Okay, let's size this up a little bit better. So with the MTM and VMM on your post-processor, you'll have the 6 standard planes there. Let's unzoom this to show you a little bit about that. So the ZX plane is going to be turning only. That's for the main spindle, as you can see. XY plane, if I rotate this a little bit, you're going to see this is the XY plane. This is for any tools that are coming from the front side or the face. In this case, it'll be these holes here and the milling around there. The YZ plane, as you can see, this is for any tool that is coming from the radial side or the top side, the X side. You have the ZX plane, which we don't have that turned on yet, but that's for the turning for the sub-spindle. And again, you have XY plane for the sub-spindle and YZ plane for the sub-spindle. So we'll work on those when we get to the sub-spindle. So let's go back to the ZX plane. And of course, you can create as many other coordinate systems as you would like. If you have holes at odd angles, things like that, and you want to create more coordinate systems, you can always create more. That's fine. These are just the 6 standard ones, which is the most common that we use. So let's start programming this. So let's open up our tools and CAM, which we have already. So the first thing I'm going to do is face off this part. So I'm going to use a roughing process along with this tool here. As you can see, as you hover over it, shows you the tool, the description of the tool. So click on that. That's going to load the tool up. And I want to do a front face here. So this is where it's going to wrap it to. I think in my document control here, let's fill in a few of the blanks here while we have it open here. I have an 1/8 of an inch material on the front, an extra 1/8 inch on the back, 4 1/4 here. Also on these two here, these are very important before we start programming. This is the clearance for the tool. So this means the tool is going to wrap it to these 2 locations before it starts cutting. And when it gets done cutting, it's going to go to these 2 locations and go home to do a tool change or go to the next process. So these always need to be bigger than these here. So let's change this a little bit. 4 1/2 is fine for the OD, and this Z, I want to stay 1/4 inch away from the material because remember we have an 1/8 of an inch sticking out already. Now this graphic part face distance, if I uncheck that, that would mean the distance between the main spindle and sub-spindle on our screen, not the machine, but on our screen, is going to be approximately 24 inches or whatever the machine actually is on your floor. But we don't want to have to pan the screen, the main spindle, the sub-spindle being 24 inches apart or longer, especially if you have a 1500 millimeter bed length. You don't want to keep panning the part on your screen. So Gibbs puts this in here as a graphic part face distance. And usually I stay between 6 and 12 inches approximately. This is just what I like on the screen, and this has no effect on your G-code output, so don't worry about putting in 6 inches or 60 inches. The G-code is still going to be the same. So this is just what it says, graphic part face distance on your screen here. Of course, we want to program in inches and diameter. That's what our machine is set for. Now these two here, we can play around with this as we get going. But as you can see in the beginning when I said I'm going to grab onto the back of the part by 1/4 inch. So that means there's going to be 1/4 inch material inside the jaws of our main spindle. And the outside here, if I look at the total width of my part here, let's bring this back up again. Let's move this out of the way. Bring up my document control. So how much is sticking out of the front? If I turn on my dimensions here, here's the front of my part. So you can see it's 1 inch from where I'm grabbing with the jaws. Then you need to add the 1/8 of an inch there. So this should actually be 1.125 is how much material is sticking out of the jaws on the main spindle. This dimension here, plus the 1/8 of an inch material we have on the front here. So everything there looks pretty good, all filled out correctly here. We're using aluminum alloys as our stock here. So let's turn off dimensions. Let's open up our facing operation again. So here I'm going to wrap it to 1/4 inch. And remember, we have an 1/8 of an inch material on the front of the part. And again, when I'm done cutting, I'm going to go back to 1/4 inch as well. We're doing a front face, the cut forward. Depth of cut, I'm going to go 50 thou. I'm going to use full, not material only. I'm going to use full. And the XR stock, I'm going to leave, actually, I'm going to leave 0 on the XR stock. So let's just fix that. But Z, I'm going to leave about 3 thou because I want to back face with the finish tool to finish that. So I want a little bit of stock on the Z, not too much, because if you back face with too much stock with a 55 degree, you'll get a lot of squealing and bad finishes. CSS is going to turn on constant surface speed, so that's normally a G96. This is the maximum RPM, so I'm going to go say I don't want to go past 2500 RPM. Surface feet per minute, 1000. Entry feed, I'm going to change that to 12 thou. You can also let Gibbs choose that by, if you define the material on here, you can see this is the material. You can change this database any way you'd like. You can add more material, modify the material. You can customize it to what you like. So when you click on surface feet per minute, entry and feed, it'll input all the values there that you'd like to use automatically. So everything else there looks pretty good. So let's zoom this up a little bit. Let's click on this front of the part right there. And let's go and make sure we're on the top view. And I'm going to take this white round marker, put it above the part there. And of course we want to face down. So I'm going to click the arrow down. And where I want to end is going to be right at 0. Okay, so let's click on do it. And I like that. That looks pretty good. But one thing I think that I want to change there is I don't want to face all the way down to Z0 because I have this hole here already and I'm just wasting time going clear down to 0. So like I said, I told you I was going to make some mistakes. So this is exactly what we're going to do. So I don't want to face first. I think I want to drill first. So I'm just going to actually move this operation down here. I'm going to clear this out. I'm going to double click here, and this time I'm going to click on holes, and I'm going to choose this 1/8" drill there. It brings up this process block here. I'm going to click on drill, feed in, wrap it out. Again, I'm going to wrap it 1/4 inch away and 1/4 inch when I'm done. Remember, there's an 1/8 of an inch material when I'm starting out. And here you can either program by the tip of the tool or by the full diameter. I want to do the full diameter. And if I turn on my dimensions here, you can see this is actually inch plus 1/8 and 1 3/8. So if I look at my document control here, I can see it's 1.25" back. So I'm going to say -1 point. We'll just say 375 just to kind of round it off. It's going to tell you where the tip of the tool is based on the tool angle there. So we'll click on RPM and plunge. RPM, I don't really want to go that fast with the jaws. If I was a collet chuck, that'd probably be okay. But if I'm using jaws, probably don't want to. So I'm going to change that to 2500. Everything else looks there. I'm going to have canned on and flood done. So we'll click do it. and it puts in our process there. I'm just going to move that to the top there. So now the first thing I'm going to do is drill it, and then I'm going to face it off. So let's go ahead and do some op sim here. We'll slow it down slightly so you can see what we're going to do. I'll kind of slice this quarter cut. So there's my drill. That went a little fast. Let's rewind it. Okay, so drill, face off. If I turn on my geometry, you can see where we cut. Turn that back off. So you can do op sim anytime that you would like. Let's turn off these here. So the next thing I want to do, I'm still going to use the tool number 2. So I'm just going to double click that, bring back that process we used to face it. But now I'm going to change this to cutting OD. So again, our rapid point is 4.5. The material is not 2.52, it's 4 1/4. That is the stock we're actually cutting from. Again, we're doing OD forward, turning, and cut depth. I'm going to go 1/8 of an inch here. This is XR, so this is radial. So it's going to take a 1/4 inch cut every time we take a pass on there. Again, RPM 2500, surface feet per minute. We'll just stay at 1,000. 12 entry feed and contour feed is just fine. I want a can cycle, so I'm going to click on that. Now we want to give it a little bit of stock to cut for the finish tool. Everything else there looks pretty good. There, we're on the main spindle. All looks good. So let's zoom this up just a little bit. I'm going to click on the chamfer, and I'm going to move this tool off there just slightly. Now if you hold the control and shift key down, you can click on the last feature that you want to cut, which is this. Now I could snap right to here, but this is where actually our jaws are, so I'm going to bring it a little bit past there. Now if I want to get more precise, I can right click and say move start endpoint by. And the Z, I could give it the start point here. Let's say the start point is 100 thou, so that's going to move this out here a little bit. And the end point here, we're going to say we're at 938 where it's at right now. I'm going to say how about 0.9? That'll move it a little bit closer there, so that's pretty good. So we'll stay 0.9, that's good there. And we'll just click on do it. And there's our toolpath for roughing. So let's do Operation Sim again. Facing off. And there is our roughing process. Okay. So the next thing I probably want to do is bore this out, because I want to bore it to relieve any stress. So when I finish this, we're going to have a little bit less stress on there. So I'm going to click on clear, double click here, and we're going to do a rough again. And we want to pick this tool here. As you can see, this is the boring bar. This time instead of an OD, it's going to be a front ID. 1/8 of an inch, 1.125 is where I want to wrap it to, because that was the drill size that I put in there. So 1/8 of an inch, 1.125 is just fine. 1.125 when I wrap it to out of the part and then back to Z. And this is where the actual material is. So these are all actually the same values here. So let's change our cut depth a little bit to 80 thou. And again, I'm going to leave stock on the X and stock on the Z. You don't need to put plus or minus here. Anytime you leave positive stock, whether you're cutting an OD or ID, it leaves stock on there. So you don't have to worry about plus or minus going the wrong direction. Again, same RPM, same surface feet per minute, and entry feed and contour feed of 12 thou, which should be just fine. Zoom this up a little bit. I'm going to probably click on this chamfer again. I'm going to go this direction. Control Shift, click on here, and I'm going to we'll just probably go clear through the whole part here. Let's go past our stock here. And again, if you'd like, you can right click and say move the start end point. Maybe the start point, maybe let's say 100 thou. That'll get it farther away there. If you want to get a little bit closer, maybe we'll stay a little bit closer. How about 50 thou? That sounds pretty good there. And click on do it. So now we have our roughing done on there. And while we're at it, we're still going to use the same tool to finish. This is aluminum, so we can still use the same tool without worrying about wearing that tip of the tool out so much. So I'm going to, you could either clear this, or if I just want to use the same tool, I'm just going to right click and say change the process. This time I'm going to just do a contour. Again, ID. If I want, I can get a little bit closer to the diameter, but this isn't really going to matter too much. It'll just wrap it here, then feed up just a little bit. Everything there looks pretty good. We'll boost this up to 1500 and we'll give it a little bit nicer finish. 7 thou. We're not leaving any stock or anything, so that looks pretty good. The same start and end point, so click on do it, and there's our finish pass there. And everything looks pretty good so far. So let's finish the OD now that we've finished the ID. So we can just either clear it or leave this contour in here and just choose a different tool just by dragging it and putting it on top of that. You can see this is tool number 3, which is our 55 degree OD. Now I don't want to wrap it OD there. I don't want to wrap it to 4.5 inches because that's going to wrap it up here, then feed all the way down here. We don't want to do that. So I want to get a little bit closer to the actual part we're going to cut. So since I'm going to back face this, I want to go approximately the bore size there. So I'm just going to say wrap it to 1 inch away on diameter wise, and 4.5 when we're done. So that looks good. 90 degree radius is pretty good. 50 thou entry there. We'll change this to 1500, and again 7 thou on the finish. Everything there looks pretty good. So this time I'm going to click on the face there, drag this marker down to where it starts on the ID of the part, Control Shift again to the end there, and I'm just going to go past this just a little bit there and click on do it. So now we have our finish pass there. So now if we do the operation sim, this should have pretty much all of our turning done. So there's our drill. And our roughing. We'll do a quarter cutaway there. There's our boring bar. Finish. Finish outside. Now if you want to color code this to, when you're doing rendering, that might help you a little bit to find any mistakes that you've made. So to do that, just click on this button right here, cut color mode, click on that and say I want every tool to be a different color. And of course you can choose the colors you want just by double clicking and change the color if you don't like the colors there. Now if I render this again, you're going to see the different tools use the color that I have over here that I chose when I click this here. So there's our finish. Now you can smooth up the rendering as well just by right clicking, go to the settings, and you can change this to custom, fast, or accurate depending on how you want this to look when you render. So now let's start programming the milling here. So let's turn off our rendering here. We'll rotate the part here a little bit to see us. I'm going to turn the stock off just to clarify it a little bit. And we're going to go to our work group milling, main and sub-spindle, so you can see it made the turning geometry disappear. Let's move this out just a little bit there. Okay, so I'm going to turn off cam. Anytime I'm messing with geometry or creating geometry, I usually turn off the cam so I don't accidentally delete something I didn't want to delete. So a couple ways you can do this. I'm going to first just probably click on this face because I need the geometry on the outside of this part as well as the hole. So I'm just going to click on this face and go to extract edges, click on do it. And as you can see, first I need to go to the XY plane, of course, make sure I'm on the right plane, And you can see that I have the outside there ready to mill and the 4 holes there. Now on this here, basically all I need to do is click right here, click on do it, and that's probably really all I need. Because this part is too big to do XYZ, because you don't have enough Y travel to keep the C-axis still, and do this hole here, 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 because you're going way below the spindle, probably farther than the Y has travel. So we need to actually do polar and cylindrical, so we're going to finish this hole and then rotate the part to do this hole, this hole, this hole. Same with the outside. There's not enough Y travel to reach all these. If a smaller part, you could, but we're going to do it using polar and cylindrical. So let's bring up our dimensions. Actually dimension some of this. Of course, should have a print, I would imagine, for any part you're working on, but we're going to dimension these anyway. So I have a 1/4 inch there, 7/16 there, and I think that's about all we need on this face here. So let's open up our cam section again. We'll clear out any old processes over here. So the first thing I want to do is probably run an end mill down through here and rough this out and maybe finish it right to size. This is just clearance for the holes, so it's not really a tight tolerance on there. So this is a 436 diameter hole. So I'm going to use a 3/8 end mill. So what I want to do is use on this one I'm going to use a contour. This is the milling section, not turning. Contour with that 3/8 end mill there. Now the first thing you always want to do before you start filling in these blanks is make sure you're on the right coordinate system. So by clicking on the rotate command, you can see which coordinate system you are in, or what you need to be in. So we have the ZX, XY, and YZ plane. We can't use the YZ plane because that's coming from the front, the top radially. We want to use the XY plane. And you want to be on the XY plane up here as well, just as a good reference here. Now we're going to do polar and cylindrical on here, so this is going to do this hole, then rotate the C-axis, go to the next hole. So let's go back to the contour tab, and we're going to rapid to, we're probably going to rapid right to actually the front of the part there. That's actually Z0. I probably want to stay, we'll stay in front of there a little bit just to make sure we're okay. And the material we're cutting is, we're going to say it's right from Z0. And as far as the depth goes, if you highlight the depth button and you hold down the Alt key, you can click on the flat face there, and that is the depth for this solid model, 5/8 of an inch deep. Entry and exit, we're going to put about 20 thou. That'll be good enough. We're going to actually cut this right to size with our end mill. Instead of going 5/8 deep in one step, we're going to go 20 thou steps, and we're going to do it as a ramp down. So basically a spiral going down this cut here. So let's just go to our home view. What that's going to do is bring our part facing our screen, our coordinate system facing the screen. I'm going to click on here. And we want to probably climb mill, so I'm going to go this direction and of course cut on the inside there. So click on do it, and let's look and see how it looks here. Just go to ISO view, and you can see our tool path is a spiral tool path. We might be starting out a little bit farther away. Let's just run this and see what it looks like, and then we can adjust it if we need to. So on the turning, I'm going to click on this little stop sign here, and I'm going to click stop before operation. Our first milling operation is number 7, so I'm going to click on here and say, go down to number 7. This way I can speed this up, so I'll rewind and speed this up, and you can see it stops right before operation number 7. You can see I have operation 6 here, so let's slow this down and let's do the rendering. Let's speed this up just a little bit. You can see I'm cutting quite a bit of air there. So maybe this is a mistake that you want to get a little bit closer to that part so you're not cutting a lot of air, especially if you want to be more proficient. So let's fix that first. Let's open that up. And again, let's wrap it to actually, let's say -1/8 of an inch. And let's say our material, we could pull geometry off this edge right here if we want to get a little bit closer. I'm just going to say -1/4 inch there. And let's click on redo. And you can see our toolpath has gotten a little bit closer to that. That's pretty close there. Let's render it and let's see if we want to make any other changes to it. So let's speed this up a little bit and slow it down then. So here's our tool. Let's actually do a transparent tool. Let's rewind, do it again, slow it down. And that actually looks pretty good. We're not really hitting any material. Of course, that's up to you how close you want to get. But it looks pretty good. So now let's just change this to do the 6 holes now. Open your process back up. Go to the rotate command. Click on 5 because there's actually 6 holes together. And we've already done 1 hole, so we need to do it 5 more times. And if we type in 360 and let Gibbs do the math, divided by 6, that's 60 degrees each time. So just click on redo because we want to redo this operation. If we click do it, it's just going to add it to the end there. So we want to just redo. And now you'll see all the holes are done there. Okay. So the next thing I want to do is probably spot drill these holes here and these holes here before we drill the 1/4 inch hole through there. I'm going to turn this off. So I'm going to clear this out, put in a hole operation, and this is going to be with the 3/8 spot drill. So I can either drag it down on top of there. So a couple ways you can get the tool in there. So again, make sure you're on the right coordinate system, XY plane. Let's change this while we're at it. So I need to do 5 times at 60 degrees. So we're going to do the first inside holes first. Let's go back to the drill command. And again, I want to, we know if I was to alt click the flat there, you can see that's 5/8. I don't want to really wrap it to 5/8. So I'm going to wrap it to 0.5. And the material we're cutting is actually -0.625. Now once you have this in there, then we can use this to have Gibbs calculate the depth we want the tool to go. Now we could do it by the tip or the full diameter, but we're kind of guessing there. But if on this diameter symbol here, if you say this is going to be a 1/4 inch hole, I want to put a little bit of chamfer on there. So maybe I want it to cut 0.2, we'll say 250, how about 270? That'll give me basically a 20 thou chamfer on there. Put in your RPM and your feed rate there. And how you want to go in. I'm just going to feed in, wrap it out with this spot drill, so that looks pretty good. So I'm going to click on this hole and click on do it, and there's my holes to cut, or my spot drill to cut all the 6 holes there. So while we're at it, I'm going to do the same thing up here with the 4 holes. We might need to change a couple things based on the depth there. Again, click on the where our material is, alt click. And I can see that's 5/8 there as well behind there. So everything else here will be just fine. So again, one thing we need to change, don't want to make a mistake here, open this up. We don't want to drill 6 holes on the outside there. So I'm going to say 3 more holes at 90 degrees. So we're already drilling 1 hole, so I need to add 3 more times at 90 degrees. So click on do it. And now I have the 4 holes on the outside there. So if I was to render this now, we have our stop on still, so let's finish the turning. Let's go back to our milling now. We have our first hole. We'll speed this up a little bit. Now you can see the part, the tool is moving around the part in an XY location. That's because we have this, this is called POV locks, stands for point of view. If we click on this, and instead of having a fixed part, I'm going to click on machine so it can actually show us what the C-axis is doing there. Let's rewind this again. And our stop is on, so let's go now to number 7. So we'll speed this up slightly. You can see the C-axis is moving, polar and cylindrical. Again, the next one. And our holes as well on there. So now we have the holes in here and we've spotted them. Now we need to do the 1/4 inch drill to drill through there. So let's do the 1/4 inch holes now. Let's bring up the 1/4 inch drill. We're still doing a drilling process, but this is with a 1/4 inch drill now. Tool number 8. Again, we're going to rapid, let's see, 1/2 inch away. That will probably be okay. Let's start out with the 4 holes around the outside. And as far as the depth go, let's click on this button here, rotate it around to the back there, use the Alt key, click on there. You can see that's minus 875. Let's go a little bit deeper. I'm going to go minus probably 1 inch. We'll just keep it there. And I'm just going to do feed in, wrap it out. It's not too thick. If you want, you could do peck full out, peck whatever you'd like here, peck chip break, whatever you'd like. Let's do 4,000 RPM, and let's just do 20 inches a minute. You can always click on the RPM and feed rate, what it suggests. Our tools on the Puma, it's usually limited to 5,000. I believe there's an option to go faster, but we'll stay around 4,000 and probably 20 for now. Peck at 1/8 of an inch and retract, we'll say 10 thou on there. Rotate, we still have 3 at 90 degrees. So let's just click on the first hole, click on do it, and now we have our drill cutting back here. We're probably rapiding a little too far away there, so let's fix that. Let's open this back up. And let's wrap it a little bit closer to the hole. Let's stay at, actually let's go to the R level here and change that. And that should get us a little bit closer to our part. And before we render, let's do the inside holes as well. So the inside holes as well, let's click on the first one there. And I think everything there is good except for the depth. Let's check the depth there. We want to make sure we're drilling at least past this flange here. So again, Alt click, and that's minus 7/8. So let's just go minus 1 inch again. And we have this hole selected, but we need to change this to, let's open this back up, 5 more times at 60 degrees. And click on do it. And now we have the smaller holes as well. So let's render this and let's see how this looks. Turn our rendering on. This time we change this to stop before operation number 8, which is our drilling. So let's render this. We'll speed this up since we don't need to look at that again. Let's slow this down. Now let's do the drilling. So there's our spot drill. There's our spot drill on there. Now we change to the 1/4 inch. And our 6 holes here. Let's take a look. Everything looks pretty good there. We have nice chamfers on our holes, and everything there looks good. Now we're ready for the sub-spindle to come up and grab this. So let's just turn off rendering, go back to the front view there. And let's clear this out. And let's first thing we want to do is get the tools out of the way. Even though the sub-spindle should clear out the tools in the turret when it's at home, I usually like the turret to be closer over to here so there's no chance of interference with the sub-spindle coming forward. So the first thing we want to do is go down here and click on this utility op here. It has a big U there, and I'm going to use the tool that's in the main spindle, the turning tool. The reason I don't use the turning tool for the back side is if I tell the sub-spindle tool to go to Z0, it's going to put everything farther to the left here, and I don't want any chance of any drills or anything going through the sheet metal on the left side. So I'm going to choose first move tool group, so that's going to move the turret, and we want to make sure we have the main tool, first tool that's used on the main spindle there, and I'm going to click on new location. I'm going to say machine home on the XR, and on the Z I'm going to put a user, and I'm going to say move this tool to Z0, so it's going to move the tool right to Z0 right here on the upper turret, but keep X at home. And I want to use the part ZX, not the spindle, but the part and the tool tip, so that means it's going to move the tool tip to Z0. So I'm going to click on that. So that gets my turret out of the way. Now I want to bring the sub-spindle forward. I'm going to open up a utility again, but this time I'm going to change this to sub-spindle in. So the main spindle is the main, sub-spindle here, just like that. The part is in the main program. Spindle on. Usually I like to have the spindle on even though I'm not doing any turning while it's transferring, because with the spindle on, we usually have the air blow come on to blow the chips off the sub-spindle, so you don't get chips stuck in the jaws. So 500 RPM is pretty good. Forward. This is the Z clearance, so I'm going to say wrap it a ½ inch away from the part. So the sub-spindle is going to come within a ½ inch away from this part. It's going to do this in a rapid. And then we're going to feed onto this and then grab it. So usually I start out at 20. The standard is 200, which is a little fast to start out with when I'm testing the program in the machine. So I usually like to do 20, and then I'll come back and change that to faster. Now, how far do I want to grip on this? Let's actually go back to our main and sub-spindle ZX plane. And as before, when we started this, I said we want to clamp right on here, which is a ½ inch back from the main spindle. So let's highlight this, hold the Alt key down, click on here. You can see that's a ½ inch right there. So click on do it. So now the sub-spindle has come forward. We're not parting this off, so all I need to do is do a sub-spindle return. So I'll drop down this arrow, do a sub-spindle return. Main spindle, sub-spindle on. All that's good. And sub-spindle return, that should be all I really need. So let's click on do it. And now we should have our part in the sub-spindle. So let's close a couple of these boxes here. I'm going to actually turn on the sub-spindle now, so you've had it off this whole time. I'm going to click here and click on the eye there for the sub-spindle. If I do an unzoom there and turn on my stock here, you're going to see there's my main and my sub-spindle. So I need to get this sol model over to the sub-spindle so we can pull geometry off this for the milling and actually bring the geometry over as well at the same time. So I'm going to turn off cam like I normally do. And I'm going to actually hold the shift key down and select everything that I have on the main spindle. And then I'm going to click on modify, duplicate, and translate. So again, on our document page in the beginning, I had 6 inches in there. So we're going to say at least move this 6 inches. That's the distance between our spindles. And our part length, if I turn on my dimensions there, you can see our parts 1 inch plus 3/8, 1 inch plus 1/4 inch plus another 1/8 inch there. So we'll go over here, 6 plus, we're going to do 1.375. So we're going to move it 7 3/8 basically. So that's going to put it over in our sub-spindle. Now we may or may not have it correct over here. This is one of the mistakes I see quite often, which is really easy to do. So I'm going to first make sure everything's in the sub-spindle. So the only thing we did here was basically copy the part and move it over 6 inches, or 7 3/8 actually. Gibbs does not know that this is in the sub-spindle. All it knows is that we took this part and did a copy and moved it over 7 3/8 inch. So when I click on this solid, if I turn off face selection, you can see both solids are highlighted. So we want to make sure we separate those before we do any movement of the sub-spindle. So let's click on the solid modeling palette, click on this separate button. That's going to separate the solids into two different pieces there. Now we want to tell Gibbs that everything over here is in the sub-spindle. So I'm going to click on this ZX plane here, my coordinate systems. And as you can see, this is purple. Gibbs changes this to purple, which is telling you this is not in the coordinate system that you think it is. So I'm going to hold the shift key down, highlight everything over here. And all I need to do is right click and say, change this to this coordinate system. And now you can see everything is associated with the sub-spindle over here. And you can see this is purple, which means it's in the main spindle. So if I go over here, you can see this is all blue, which means this is the main spindle. Everything's purple over here. This is in the sub-spindle. So pretty easy to distinguish which is which. Now if I want, I can turn off now the main spindle. So when I go to no zoom, it just zooms up the sub-spindle here. So what we want to do here is, of course, finish turning this and then finish milling this. So I'm going to turn on my cam again, clear out anything that's over here. So the first thing I want to do, again, just like we did on the main spindle, is face this off. So I'm going to bring up a roughing process. This time it's going to be with the sub-spindle tool, the 80-degree diamond. Front face. Make sure you're on the sub-spindle, not the main spindle. Everything there is about the same as before. Cut depth, I'm going to change this to 50 thou. XR stock and zero that out. I only need stock on the Z. Everything there looks pretty good. Okay, I'm going to click on this face here. Cut down, so starting from the top and cutting down that direction. I'm going to move this up here because we still have stock over here at 4 1/4 inches. But we have the hole clear through, so I just need to bring this probably a little bit below there, and you can always right click and move it to exact places you want to go, but that's pretty good there. So there's our facing there, but one thing I want to do that I noticed, like I said, I'm going to make mistakes here on purpose. You can see the front of the part here is not equal to the face here, so let's fix that. So this will be a common mistake a lot of people will make. I want the sub-spindle Z0 to be right at the face there. So if I was to dimension this, you can see the Z is 1/8 of an inch from our coordinate system. So I want to move everything basically forward from there. So I'm just going to click on here, turn this off. And I'm actually going to translate that. Now this is the positive direction, so I want to move the Z 1/8 of an inch. Now you can see this changes to Z0. The front of my part is actually at Z0. So we fix that. Normally I fix this before I start doing the toolpath, but that's okay. We did a little bit differently. Now on the sub-spindle, we need to, of course, there should be an 1/8 of an inch material on the front of this, so let's go to our document control. And we haven't changed anything on the sub-spindle yet, so let's click the arrow down, go to sub-spindle, and you can see we need to add the 1/8 of an inch there. And our diameter, and there is everything looks pretty good there. We just need to tell it how much stock is actually sticking out of the spindle. So for here, what is sticking out and what is holding into our jaws? Remember, we grabbed onto the part 1/2 inch, so inside the jaws is actually 1/2 inch. And if we take our overall part length, which is 1 3/8, so we'll just type that in. That's the overall length from including the stock on both sides there, so that's 1 3/8. And we grabbed on a 1/2 inch there, so if I click on minus 0.5, so we're actually 7/8 of material is sticking out there, and we have an 1/8 of an inch material on the front there. So everything out looks good. Clearance plane looks good. Graphic face is the same. Now you have this box that says initial stock. You can see if I click on that, that adds more values in here. What this means is if you had stock already in the sub-spindle before you started machining, but we don't in this case. So now we'll go through the rest of the processes there. So again, we're facing this off. Let's redo that. That fixes our roughing operation for the face. Now let's use the same tool, and we need to, of course, rough the outside. Open up this process, go to OD this time. We don't want to start at 1 inch, so 4.5 is where our material is, our clearance, and 4 1/4 is the actual material here. Everything there looks pretty good. Let's add 10 thou stock there, 12 thou, we're roughing. Everything there looks pretty good. Let's go 100 thou there on their depth. And again, let's click on the chamfer, start out a little bit there, and maybe end, go this direction. Of course, maybe end right at this point here so we don't recut that. And click on do it. Okay, now let's do a boring bar. So we need to bore this out and take a finish pass. So let's use the same roughing process, just change tools. So I'm going to take this tool here, which is our main, actually come down here, which is our sub-spindle boring. Let's just drag that tool on top of there. And do front ID again. Everything there is the same as before, leaving stock. Everything there looks pretty good. Let's change this to 80 thou. Zoom this up, click on the chamfer, start outside our part, Control Shift, and it's actually in there and right on that point there. We'll go a little bit past it actually when it cuts, and redo, not redo, but do that toolpath. Now let's do the same thing. Let's just clear this out and finish with a contour with that same boring bar tool. Front ID, make sure you're on sub-spindle. Everything there looks pretty good. Speeds and feeds look pretty good there. We have the same shape selected almost. Let's start out here a little bit and finish. We'll actually finish on this chamfer a little bit past there. And click on do it. Now we have our OD and ID finished on here. So let's save everything, then let's do a cut part render to see where we're at. Let's first turn off our dimensions. Let's open up our op sim, rewind, and I'm going to click on this stop sign and tell Gibbs to stop before part unloads, or basically goes over to the transfer location for our sub-spindle. So let's play this. Actually, we need to turn on, if you want to see the main spindle, make sure you turn the view on. So let's rewind this again, play. And let's speed all this up. Let's watch the transfer now to the sub-spindle. And there's our sub-spindle turning. If I were to do a cutout, you would see our main spindle work good, sub-spindle. Now one thing you're probably noticing is, wow, I forgot to cut the flange on here. Everything went to the sub-spindle. Everything looks pretty good there, except I forgot to cut the flange. Well, that's okay. Easy mistake. Let's fix that. I'm going to probably turn off the sub-spindle for now, just so we can see the main spindle here. And I'm going to first clear out the processes here. And I'm going to put in a contour there with that 1/2 inch end mill. And again, always make sure you're on the, of course, the right rotation. Make sure you're on the right spindle. In this case, we're not on the sub-spindle, we're in the main spindle. And make sure you're on the, not the ZX plane, but you need to be on the XY plane. I don't want to do it 5 times at 60 degrees, so I'm going to zero those out, but I want to do polar and cylindrical. go back to the contour. Let's go back to our milling on the main spindle. And there's our geometry. Turn this off just to keep the clutter off. And I'm going to rapid. Let's alt click there. That's 5/8. I don't want to rapid there. I'm going to rapid to minus 0.5. And this is, of course, alt click there. You can see that's 5/8. Quarter inch away when we're done. And as far as how deep I want to cut, I'm going to rotate this around just a little bit. Alt click the back side there. You can see that's 7/8. I'm probably going to go minus 0.9. That'll get me a little bit past without actually running into my jaws. I probably want to do kind of an entry and exit there, a nice transition there, maybe quarter inch on both of those. And it's probably a little much to do it in one pass. Let's take a look and see. I don't want to do a ramp down. Let's do a 275 depth of cut is just fine. I'm going to leave a little bit of stock for finish there, and put in our RPM and feed rate. Like I said, depending on what options you have on the your Puma or Lynx, will depend on if you can use this RPM or not. If not, you change those. So let's start up here. Let's actually go to the home view. Let's actually start right there. And we want to climb mill, so we want to go this direction. Go back to the isometric view. And click on do it. Well, actually, before we click on do it, I don't want to put it at the end of here. I want to do it before the sub-spindle transfers over, before we grab the sub-spindle. So I want to put it right in between operation 11 12. So by doing so, just click on this little triangle right here and click on do it. And then you'll see the entry and exit there. Looks pretty good. Now, if I don't want a witness line there, it's starting right at this tangent point. I could also open this up and say, let's do a 100 thou overlap there. Let's click on redo. You can see we have a little bit of overlap there. Now let's render and let's see if this is really what we want to do. So I'm going to turn on the rendering. But before I do that, I want it to stop before operation 12. So I'm going to turn on the stop sign and say, I want you to stop before operation 12. That way I can speed this up so I don't have to wait watching it render. Okay, now let's slow it down. Let's see what it looks like. Pretty much too deep of a cut, I would say. You're probably going to snap your end mill or not be able to evacuate the chips. So let's fix that. Let's open up this process and say I want to do 2 more extra offsets. And maybe we're using a 1/2 inch end mill, maybe 200 thou extra steps, leaving stock there. Now, since we're going to use the same tool to finish, I'm just going to put a second process in there with that same tool. Everything else will be filled in for you automatically here because it's just taking everything we did on the first process there, except now I want to do 0 and 0 stock for the finish. Okay, so let's, we have this operation highlighted already, so just click on redo, and now we have our 3 separate cuts. Let's, again, operation sim. Okay, let's slow it down. Much better. Second pass. Third pass, and then our finish pass. Then our finish right here. Now everything looks pretty good on the main spindle. Now let's finish this off by making sure our sub-spindle's back on. Speed this all up here. Actually, let's rewind it and start from the beginning. Okay. There's our milling. Transfer to the sub. Okay, now we need to finish off the backside there, and then the reason you're seeing some of this in the sub-spindle is we haven't unloaded the part yet at the end. So everything else here is almost done on the sub-spindle. First thing I want to do though, before we finish off, is I want to deburr these holes with the 3/8 spot drill before we finish off. So let's clear this out. Let's go to our XY on the sub-spindle and our milling on the sub-spindle. We haven't pulled any geometry off of the milling on there. I'm going to turn off cam for a moment. I'm just going to click on face selection, select this face, and extract the edges. And I'm going to click on this face and do it the same thing there. So now we have all the holes we need. Really don't need this. We can leave it in there, just delete it. Doesn't matter. Really don't need that there either, unless we're going to chamfer that, which we might do. So now I need to turn on my cam. I'm going to choose a hole process with the sub-spindle 3/8 spot drill, combination spot drill chamfer tool. Feed in, wrap it out. Make sure you're on the correct spindle first. And first let's highlight this, alt-click. I can see that's, well, first I want to make sure you're on the correct plane, which I'm not. So make sure you're on the XY plane. Now if I alt-click, you can see that's better. That looks a lot better. Click on the front there. There's my rapid 2-point. That may be a little much. I may stay 1/4 inch away as well. And again, put in the diameter you want to cut, 0.270. There, again, rotate. Well, since it already has 5 and 60 in there, we'll just do the inside holes first. So I'll click on the first hole. Let's actually go to our home view. We want to get make sure the X is on the positive side, so we're not trying to go underneath the spindle. So that'll be a good one there to select. And let's click on do it. So that'll be our holes on the sub-spindle to deburr. Be a little bit easier to see there. Now we need to do the same thing with the outside holes. It's the same depth and everything. So let's just choose this hole here. Go to our rotate command, change this to 3 more times at 90 degrees. Click on do it. And now we should have deburring on the sub-spindle. So let's rewind it. Let's move it over to here. Let's do a sub-spindle view, Operation Sim, and see what we have. Turn our op sim on, slow it down a little bit. Let's turn off the geometry as well and play. And here we have our main spindle. Let's finish off the flange. Now we're going to do the transfer to sub-spindle. Face it off, bore, and chamfer. So now our part looks pretty good. Looks like it's all finished. Now maybe we want to deburr the outside. Let's just show you that with the same tool. We're going to actually use the 3/8 end mill spot drill, combination spot drill chamfer tool. Let's go to the milling on here and clear this out. Let's put a contour in here with our 3/8 spot drill chamfer tool. Again, make sure you're on the sub-spindle, make sure you're on the XY plane. Polar and cylindrical is what we want. Our material again is actually 1/4 inch there. I'm going to wrap it to actually 1/4 inch there. And since it's a 3/8 spot drill, I only have let me bring this up here. We only have 1/8 of an inch to play with here before we start cutting on the flat side or the straight side on here. So again, I'm going to click on there, 1/4 inch, and I'm going to go minus, we'll say 1/8 of an inch there. That'll get me pretty much on the close to the diameter of there, instead of cutting with the tip. The tip, usually you don't have very good finishes. I don't need really overlap there, so let's zero this out. But this is the stock. How much do I want to leave? If I put 0 in there, it's just going to barely touch the end mill, the chamfer to this edge there, so it might deburr it, but it's really not going to give us any kind of chamfer. So I want to put a 20 thou chamfer. I'm going to say minus 20 thou there. Let's just click on, let's just go to home view to make sure the X is on the high side there, which we want. Okay, that's what we want there. And click on do it. And let's rewind that and see where we're at. Slow this down. Let's actually run through the whole thing again. Okay, we'll transfer to the sub. We'll stop it before the chamfer. Slow it down. And there's our chamfer. Looks like we're staying away from this surface here. So we have our nice little chamfer on there, so the part looks pretty good. We didn't do any chamfer on the front. Now if we wanted to, we could go back and do the same thing on the main spindle, and we just need to click on the operation in between the operations, which we want to do the chamfer on there, but it looks pretty good. Now the last thing we want to do, so if I rewind this, click on OpSim again, and rewind this, you can see right now there is still material in the main and the sub spindle, which we don't want. We don't want any material in the sub spindle when we're starting off, because we're going to transfer over, and if we don't unload this, it figures the part is still in the sub spindle and it's going to come over and crash into our main spindle. So we want to make sure we unload that. So let's just clear this, and the last thing we probably want to do is a utility, and actually probably no tool. Click the arrow down, and there's a couple different options on the Puma Lynx, and that is parts catcher in, parts catcher out. If we want the parts catcher in, we'll click on that, and we want the parts catcher on. Yeah, the only choice we have is main spindle there. That's fine. So normally on some of the machines I usually put 8 inches, so I bring the sub spindle up 8 inches so it's right under the parts catcher, and click on do it. So that's going to put your M codes in to bring your parts catcher in. Now the next thing I want to do is, of course, unload the spindle. You have auto chuck or you have parts catcher. So if we do the parts catcher, sub spindle, that's great. So we'll click on that. Now we have that. Now the last thing we want to do is probably bring the parts catcher back out. Click on that. And that's good. Now when we start off in our rendering, you'll see there's nothing in the sub spindle there, which is how we want it. So if we run this completely through, let's turn off all the stops there and just let it run through the whole thing. We'll do a cutaway there. The only problem you can see there is, of course, our screen is blank because we unloaded everything. So if we want to see the finished part before we unload it, where we start to unload it is operation number 26. So if we go back to the rendering here to finish off, and we do stop before operation 26, that should show us the part before we unload it. So let's rewind, click play. And let's turn off the section view there. And if we look at our part, looks very good. Everything there is done. Main spindle, sub spindle, everything looks okay. Now if we finish this off, you're going to see it disappear, of course, because it went into the parts catcher. So this is how to run the Puma. We'll post the code here just so you can get an idea of what the code looks like, so you have a better idea how we program the Lynx and Puma machines. So let's bring up this post here. I have a Puma post here, a popular one. Let's click on process. As you can see, this is our first operation. Here's our 80-degree diamond for the roughing. and the roughing of the OD. Now this one I didn't do can cycles. As you can see, this is longhand, but if we check the box that says can cycles, we would get the G72 on here. But as you can see on the OD roughing, we have the standard can cycles double line format. Here's the inside boring bar, double line again. Let's get down to some of these other operations here. Here's our milling, finish end mill. Now here is the transfer here. You can see we wanted to get the turret out of the way first, so we brought up the tool number 2, and we went to actually Z0, so that brought the turret out of the way. Then we have the sub-spindle coming forward, opening the jaws. Here's our RPM, and this is where we're going to go back home and move on to the part, and then of course open the jaws and go back to our sub-spindle return. And there we're doing work on now the sub-spindle there, and depending on what work fixture offsets you want to use will be depending on the customer's use. In this case, sub-spindle G55, which is normal. Here's our can cycle again, and the rest of this stuff here, parts catcher in, parts catcher out. So with the post, when you purchase the post from Gibbs, you have up to 6 months to have Gibbs make any changes at no charge. So you can have Gibbs modify this post how you like it to run, what fixture offsets you would like to use in the post, and how you would like the things to go. So this would be pretty much customized for how you like to run your machines, because not everybody's the same. Some have high pressure, some don't. Some have different M codes for the high pressure, but that can all be modified in your post very easily in Gibbs. And like I say, once you purchase the post, you can have all that changed so everything works perfectly, so you don't have to do any editing on your program. So hopefully this helps learning how to program the Doosan Lynx and Puma machines, and thank you for watching.